Oh, it's kind of
Okay, let's solve leak code 198 house robber. In my opinion, this is such a good question to understand. Even though it's just an easy question, you can learn so much about dynamic programming from this problem. And you might already know, Google really loves asking dynamic programming problems, and if you want to get started on that, this is such a good question to understand. So we're basically given an array of integers, like many problems, and each integer represents a house, right? So this is a house, this is a house, this is a house. They're all houses and they're adjacent to each other. So it's basically a neighborhood. We want to rob houses to maximize the amount of money we can rob. So why not just rob all of them, right? Nope, there's a restriction. We can't rob two houses that are adjacent to each other. So we can rob this house, but then we can't rob this house, right? So we have to rob this one next, maybe, right? On the other hand, if we rob this one, we can't rob this one and we can't rob this one. It has two neighbors. This might sound really difficult, right? So let's just start out with the brute force approach. Let's
that's only
imagine if we
dog.
were
What the
trying to get
fuck?
every single combination. Okay, so the first combination is where we pick the first house, right? So let's draw out what the decision tree of that would look like. Okay, so our first decision was to rob the house with value 1. Okay, so next we want to rob more houses, right? But we can't rob this one. So to rob house 1 and is right, we can't be our result. Now this is a can't rob house 3. So the only house left is house 1. So we rob that one as well. So if we went along this pathway in our decision tree, we would get these two houses robbed, and that's a total of 3. But we remember we found this, which was a total of 4, which is greater, of course, so that's going to be our result. Now, this is a very brute force approach. Imagine if we had more numbers here, right? Maybe a 3 and a 4, then we'd have to have like more paths in our decision tree. This could get very complex. So how can we improve it? Can we identify any subproblem? And the answer to that is yes. Let's take a look at the subproblem. So remember, we have two choices. We want to get the max that we can rob from this entire neighborhood. So the first choice is we rob from the first house and then find the maximum from the remaining houses, right? Imagine there's more houses here. There could be a 3, a 4, whatever, right? This is the subproblem. We're finding the max of a subarray of the entire array. The second choice we have is we skip this house, right? If we skip it, then basically we're saying, okay, find the maximum of the entire subarray, not including the first value. So let's actually write out the relationship if it doesn't make sense yet. So if we want to find the max we can rob from the entire array, we have two choices. Rob in this case indicates the max that we can rob decision. If we decided to rob the first house, then we're going to break up the problem into a subproblem. Now we got to only these two. Now before we're going to do a point, just each value have the value computed right here from, because if board here. So now let's look at the code. Since we only need to maintain the last two maxes that we could rob from, we'll only need two variables. So I'll just name them rob1, rob2. We'll initialize them as 0 because if we get an empty subarray, we want to return 0 anyway. So let's iterate through each of the houses we can rob. And now we want to compute the maximum that we can rob up until this value n. So I'm going to compute that in a temporary variable for now, and you'll probably see why. So the max we can rob up until now, in my case, I'm going to say rob1 or rob2 was the last house that we robbed. Rob1 was the one before that. So knowing that, the max we could get would be n plus rob1, meaning there's a gap between the current house and the previous house, or rob2, which includes the previous house. In case it's not clear, this is basically, let me just make a comment to show what I mean by rob1 and rob2. So rob1 is first, rob2 comes second. I have to rob1 with n because it's, and rob2 in this case wants to be updated to n. So rob2 can now equal our temporary value that we just computed. At the end, we want to return rob2 because by the time we get to the end, rob2 will be equal to the last value, meaning that it will be the max we can rob from the entire neighborhood of houses. This is a problem you can learn so much from. Even though it's an easy problem, it might take you a while to digest exactly what's going on and to understand all the importance of this problem. So many dynamic programming problems are built upon this one. And let me know if you have any questions because I feel like I might not have explained the recurrence relationship quite well enough. But if this was helpful, thank you for